Let's discuss about the comparison of silicon acrylate, ferrosilicon acrylate, and perfluoroether in our third part of this video of RGB. So, what I also wanted to add is a plasma treatment. Okay, so I think uh, that's important point in RGB. So let's discuss about first the comparison and then chemistry comparison. As I've already told you, silicon uh, seg- segment in acrylate bond in silicon acrylate and fluorosilicon acrylate silicon we add fluorine. Yes, in perfluoroether heavily fluorinated ether chain and very uh, fluorophilic. So oxygen permeability definitely increases from silicon acrylate to fluorosilicon acrylate and from fluorosilicon acrylate to perfluoroether. It's very high oxygen modulus of elasticity, moderate to high in silicon acrylate, at the same time moderate balance in fluorosilicon acrylate. Variable, it depend upon the engineering how it does and how many cross-linking chain is there in perfluoroether. So durability of chemical good, but silicon can be crazy. Yes, it can be brittle and better than the silicon acrylate is fluorosilicon acrylate, definitely better than silicon acrylate. But durability of perfluoroether excellent chemical resistance and durability. Need for surface treatment coating is usually for every lens there is surface treatment or coating is needed. Yes. So the other comparison is weightability and tear spread is moderate in silicon acrylate, basically moderate or poor, better than silicon acrylate in fluorescent acrylate, and often low with the perfluoroether. So basically needs treatment in perfluoroether. Lipid and protein deposition is lowest in perfluoroether, but more in lipid deposition in silicon acrylate because of hydrophobic nature. Water and tear interaction, low weightability seen in silicon acrylate, and least interaction unless treated is perfluoroether. That's why plasma treatment is important there. Good comfort. So good comfort is excellent when the weighted but may feel dried otherwise. So weighted perfluoroether is very good. Often best oxygen and comfortable balance in fluorosilicon acrylate. That's why fluorosilicon acrylate is still in the market and doing well. And traditional clinical uses, traditional RGP need high O2 and rigidity. So most modern RGP orthokeratology specialty fit in fluorosilicon acrylate. So especially high oxygen lenses and low wear and heavily deposit environment is perfluoroether is better. Yes, highest oxygen permeability, and if environment is too much deposits is there, so potential of deposit is there, then perfluoroether is better. Main advantage is high O2 and strong phase retention and prolonged history. But silicon acrylate compared to others, we put it aside. Yes, silicon acrylate balance high oxygen O2 level deposit better weightability potential, but oxygen is extreme in perfluoroether, superior deposit resistance, and chemically inert is perfluoroether. So many disadvantages: hydrophobic and deposit and comfort issue and needed coating is silicon acrylate, and more complex, costly to manufacture is for fluorosilicon acrylate. But at the same time, expensive, hydrophobic surface need wetting treatment is perfluoroether. But these are the disadvantages of perfluoroether. Okay, so let's discuss about the plasma treatment, which is very important point in current market. Yes, current scenario. What is plasma treatment? Plasma treatment is surface cleaning and modifying process done in rigid gas permeable contact lens. So it's not coating. Just remember, it's not coating. There is nothing we coat over the contact lens. It's treatment. Okay. So basically, surface is cleaning and modifying process done in rigid gas permeable lenses. The lens is placed inside a special reaction chamber. Then inside the chamber, gas is turned into the plasma and high energized state matter containing ion and electron. This plasma bombards only on the surface of the lens and removing contaminants and slightly charged, changing surface chemistry. Basically, this plasma will bombard in the surface and remove the contamination from that surface. So that's why it's not a coating. I have already told you it's not a coating like something wax or something polished over the surface. It's not a coating. It's a true surface treatment. Yes, it's a surface treatment, not a coating. So plasma treatment, why it's done? During the manufacturing, typically when contact lens is manufactured. So tiny unpolished surface can be there, tiny polishing residue can be there, or contaminants can be there, and can be stick to the surface of the lens. So whenever we treat with a plasma treatment, then surface becomes smooth. Yes. So many new high decay oxygen lens material naturally less wettable and can attract deposits. So it's always there. So plasma treatment remove this residue and make the lens more hydrophilic. That's the point. First, it will remove the residue, that unpolished thing, that residue remains in the contact lens. And then what it does make contact lens more hydrophilic. That's why plasma treatment is very good, but it has disadvantages too. And main cost, we should be cautious. So let's discuss about it. The process, what is defined roughly in this slide, is a process where GP are expected to plasma gas reacts damage and deeply clean and modify the lens surface, not coating. Definitely, it's cleaned surface. Yes. Mechanism is plasma energize neutrons, positive ions, and electrons, remove the polished surface basically, and increase the surface hydrophobicity without affecting the bulk material property. It doesn't uh, change the material's property, but at the same time it doesn't coat anything. It just remove the residue and make surface more hydrophilic. So benefit is extreme clean and wettable surface and reduce wetting angle. Yes, definitely reducing wetting angle means being more hydrophilic, isn't it? So that's why if it's being more hydrophilic, so initial comfort of the contact lens will definitely go. Yes, and enhance the initial wettability of GP contact lens. But limitations, but because precautious, we must be cautious. What is the limitation? So effect duration on long term comfort is unknown, because short term, yes, definitely, but long term we don't know. So, but one thing we must be cautious is abrasive cleaner and inofficial polishing can create negative treatment to the surface. So it's can create uh, can be can vanishes the advantage of plasma treatment if we do use abrasive cleaners. It must be used. So uses in trend increasingly offered by GP labs for a small additional fee due to the improved initial comfort and weightability. So basically, GP labs does all these things. Okay, you have to learn more about plasma treatment, because currently in GP contact lenses, more and more plasma treated contact lenses, and we have been practicing these things, and even in scleral lens and all these things. So you must be cautious about this technique. You must know about this technique. Okay. So I think that's finally the reference. I have taken a lot of pictures from this book, which is very good book, and definitely Efron is lovely book. There is no question about it. And Contact Lens by Phillips is another lovely book. It's sixth edition. Just to read sixth edition. In this particular case, yes, fifth edition is better. In newer edition, I have shown this newer edition, and this is second edition. I think both all the books from, I think it's 2019 book, 2019, it's 2024 or 23, it's 2000 also 19 or 2019, yes, I think 19. It's recent books and they are very good books. So I think these three books will make a great combination. And Afron's another book for complications of contact lenses, great book. So these are the books for optometry student will be sufficient enough for your journey. So I think that's all. Bistan. Cheers.